Now we are solving December 2018 question paper, and in today's class we are going to see the second part. Next question says that a single phase transformer has 1000 turns on the primary and 200 turns on the secondary. It means what? 1000 on the primary. So NP is 1000. NS is 200. Okay. Then it says that no load current is 3 amperes. So I naught is 3 amperes. Power factor, it means cos phi naught is 0.2. Secondary current, which is IS, is 280 amperes. And a power factor, it means cos phi 2. This can be also regarded as I2. Sometimes we refer to this current as I2. Fine. 0.8. Okay. So now we have to calculate magnetizing component, that is Im or I mu. Then we have to calculate the loss component, that is IC. And then primary current, power factor. Fine. So let us start with this. Now we know that the relationship between primary current and secondary current and the number of turns is given by this. Okay. So let us convert this equation in terms of primary current. So that becomes the secondary current multiplied by NS upon NP. So we'll be putting the value. What was NS? That is 280. Sorry, IS. And how much is NS? 200. How much is NP? 1000. Yes. So the primary current comes out to be 56 amperes. So we have calculated primary current. Okay. Now we will be talking about this, the remaining thing. So here we will require these components, all the power factors. Okay. I'll do one thing. Yes. So see, cos phi 2 is given, right? 0.8. What I'll be doing is I will be finding out phi 2, which is cos inverse 0.8. And by using this, I will find out sin phi 2 because I require it. So sin phi 2 comes out to be 0.6. Similarly, cos phi 0 is given, which is 0.2. So I will find out sin phi 0. So that comes out to be 0.98. Okay. Now you have to pay attention. Now what will be my phasor diagram? By using the phasor diagram, we will be able to resolve all other things. Okay. So here is my phi. Here we have V2 and E2. So opposite to this we have V1 and E1. Okay. Here we have I2. Please pay attention now. Now this is nothing but phi 2. So what we are doing is we are extending this current here. So this becomes minus I2. Somewhere here is my I0. That is the no load current. Okay. So I have to take the resultant of this in order to find the resultant current. Understood? Now how will I find this resultant current? So for this we have to resolve I naught. Okay. We have to resolve I naught. Now if this is I naught, how will I resolve it? I will resolve it to be I naught sin phi naught. Similarly, I will resolve it to be I naught cos phi naught. Okay. Similarly, here I have I2. So again I will resolve it to be I2 cos phi 2. Similarly, I2 sin phi 2. Okay. Now in order to find the horizontal component of I1, okay, the horizontal component of I1, what I have to do? I have to add the horizontal component of these two. Similarly, in order to find the vertical component of I1, I have to add these two components. Understood? Okay? Yes. So now see, I am finding the horizontal component. So horizontal component will be I1 cos phi 1. So what did I say? That we have to add the horizontal component of both the currents. So that will be this. So how much is this? It is 56 into 0.8 plus 3 into 0.2. So I1 cos phi 1 comes out to be 45.4 amperes. But remember, this is horizontal component of I1. Similarly, vertical component. So that will be I1 sin phi 1. So what will be this equation? Come on, repeat it with me now. It would be I2 sin phi 2, yes, plus I0 sin phi 0. Now we have all the values with us, right? So that comes out to be 36.54 amperes. So now I have horizontal component and I have the vertical component. Now I know how to take the resultant, isn't it? Now I have, see, horizontal and vertical component. So in order to take the resultant, what should I do? How to take this vector resultant? Yes, I have to square them and then take the square root. So it will be 45.4 square plus 36.54 square. Fine? Yes. So I get the resultant to be 58.3 amperes. Now this is the resultant current. Okay? Fine. So how will I find the magnetizing component? The magnetizing component and the core loss component. How do I calculate that? It is I0. It is I0 cos phi 0 and this is I0 sin phi 0. Correct? So how much is I0? I0 was 3. Sin phi 0 was 0.6. So this comes out to be 1.8 amperes. Similarly, I0 was 3. How much was cos phi 0? Cos phi 0 was 0.2. Right? Just so this component comes out to be 0.6 amperes. Fine? Okay. Now how will I calculate phi 1? Resultant current has been found out. Now how to calculate the phase shift? Phase shift can be found out by calculating tan phi 1. So it will be this vertical component upon horizontal component. Okay? Yes. So that becomes 36.54 upon 45.4. So that comes out to be 0.805. So phi 1 comes out to be tan inverse 0.805. This is 0, okay? Eight zero. So phi 1 comes out to be 38 degrees. Now what will be the resultant power factor? Power factor will be cos phi 1. So that comes out to be cos 38 degrees and it is 0.78. Of course it is lagging. So this is my answer. Okay. I hope you understood this. Next question. Question number 3b. Derive the formula for resonance frequency for the circuit with pure capacitor in parallel with a coil having resistance and inductance, and we have resistance. Now again in chapter 2, when we dealt with resonance frequency for parallel circuit or parallel resonance, we have derived this equation and we have also discussed, we have also discussed dynamic resistance. So you can please refer to that lecture. So with this, we end today's lecture. We shall be meeting with more questions in the coming lecture. Thank you.